Hi, John Puglisi here, Superintendent Rio School District, bringing you a math art lesson called Carla's Caterpillar, La Oruga, developed by Steve Clark, a colleague of mine, lives in Mexico for a long time, with a student whose name is Carla. This is Carla's discovery. It's about special case right triangles, it's about progressions, it's about Pythagorean theorem, but it's also about making, thinking, learning all at the same time. So let me show you a couple documents. First document is Carla's Caterpillar at the centimeter level. Another thing that we're working on is scale. We have a lesson for you that you can make it at the centimeter scale, at the inch scale, and at the 1 foot scale. You can make it at any scale, but we're going to show you the beginnings of the centimeter and then the inch. So here's the centimeter side. We begin on Carla's Caterpillar also with area. So here are a bunch of squares, and these squares all have a number inside. The number inside is the area, so square centimeter. So there is what we call the unit square, 1 by 1 by 1. This one right here is not a 2 by 2 by 2. This has an area of 2, which means it has the square root of 2 going all around. The side of a square is also its square root. So you're also going to learn about square roots in this lesson. The idea of Mr. Clark and I's math lessons are always, they're not only scalable from size like centimeter, inch, and beyond, they're scalable for people. So you could be a preschooler and you could probably go all the way through to calculus and beyond, and there are things to learn and things to do doing the exact same lesson. Here is Carla's Caterpillar already made. You see, it begins with 2 unit squares. There's a 1 by 1 and a 1 by 1, and inside there's a triangle. You have on one side of the triangle a 1, another side a 1, and then we get that hypotenuse. We cut that in half, and we know that a squared plus b squared equals c squared, that this triangle inside is a 1 by 1 by square root of 2 triangle. But we're just going to show you that. Your first task, we start with easy cutting and pasting tasks that anybody could do. I call these the butterflies, and you see the butterflies are made up of 3 squares that surround our special case right triangle. We want you to cut around the perimeter of one of the butterflies. You're just going to glue it onto the right place in Carla's Caterpillar. That's the first step. Okay, so check it out. I got one of the things that I call a butterfly. There is the area of 9, the area of 10. All of the triangles have 1 on the outside of the triangles. The thing to think about in Carla's Caterpillar, or La Oruga, is how are the triangles changing? They are changing. One part doesn't change. One side is always 1. This side of the triangle is 1. This side is the square root of 9, otherwise known as 3. People know that. And this side is the square root of 10. I got to find it on the template. So there we go. I glued it right over top. The butterflies have wings in common. So I'm going to go over and look for the 1 by square root of 9 by square root of 8 triangle, which happens to have a green triangle, and I'm going to cut the perimeter. Perimeter means outside. It's like walking the fence. Perimeter of a shape is like a fence. It's walking the outside. The stuff inside is called area. This lesson is also about area. It's about a lot of things. That's one of the things about the lessons that Mr. Clark and I will build in math and in art. They have many, many ideas and things, but you can discover them or understand them in many different ways. Okay, so there's my 1 by the square root of 9, otherwise known as 3. So 1 by 3 by the square root of 8, skinny little triangle, and I'm going to glue that. And check it out, though. It has a common number 9, so I got to put that butterfly right on top of that butterfly. And I'm not going to do all of them, but you can see when you're done, you'll have a beautiful colored, and all they are doing, all of your students or even your adults, your learners, they're just coloring it and they're trying to understand and see what the relationships are. You don't even need to talk about them. They'll start understanding what the relationships are. How are the triangles growing? How are the squares growing? The ones are constant. So that is the centimeter.